Hi guys, welcome to another episode of MrLopezClasses.com. This is our diesel engine class. This is the chapter 9 dedicated to pistons, piston rings. And we are going to check at the end of this episode the analysis. We are going to verify what happened with the piston rings, with the combustion chamber in different situations. When the mixture is lean, when the mixture is rich, when salt water enter, when coolant enter, when excessive amount of oil enter. We are going to analyze what happened with the piston and the piston rings. And we are going to do the same analysis later in other chapters similar to this one, but we are going to include the OBD2 codes related with that specific problem. Okay, my friends, we are going to start with the installation of the piston and the piston rings. Once again, what is the first step? Yes, my friends, check if you have the service manual. The service manual is the most important part. Check that you have exactly the service manual according with the series, with the model of the engine, the family engine. Be 100% sure that this is exactly the manual that you need, because in this specific example today, we are going to analyze the tolerance in between the piston and the cylinder wall, and we are going to verify if the clearance are according with the manufacturer specifications. Those clearance, we are going to verify if at the bore on the cylinder and the diameter on the pistons, the difference between both of them are according with the information in the service manual. This is critical. This is the most important part. All right, we are going to check the bore of the cylinder. We are going to verify the bore of the cylinder. We can use this special tool with the dial indicator. This is good. Or we can use this one, and we are going to verify with the caliper, with the internal diameter caliper, and we are going to verify according with the manual if the bore is exactly in the range of measurements according with the manual. Very, very important. All right. And after that, we are going to continue with the lubrication of the cylinder and the lubrication of the piston before we install the piston inside of the cylinder. All right, we are going to verify the lubrication. We are going to check, we are going to lubricate with your hand. Lubricate the cylinder and lubricate the piston also. A lot of oil in order to verify that the procedure is according with the manufacturer recommendation. This is a generic procedure for any type of engines. All right, you lubricate with a lot of oil the cylinder and the piston. Okay, and after that we are going to prepare the tools to compress the rings. There are millions of tools to compress the rings. You need, with your experience, take a decision. In the future, I am going to use this tool or this one. That depends on the engine. I love the tool that I have in this video, but for gasoline, I prefer other ones because the pistons are smaller. In this particular example, I use always this tool. This tool is excellent, and I compress the rings, and immediately you compress the rings. This is my recommendation. Pass your finger internally and touch that all the rings close properly. Any ring is a little open. If you have some ring a little open, try again. Remove the tool, put it back the tool, and compress the tool again. And pass your finger carefully and verify that all the rings are flat with the surface of the piston. All right, exactly like this. Yeah, you pass the finger and you verify that all the rings are fully compressed. What happens if the rings are not fully compressed? When you try to introduce the piston, the rings expand and the piston never enter. Hey, my friend, this is other important recommendation. When you try to introduce the piston, if you feel that the piston is hard, don't try to introduce with a hammer. You need to remove the tool, remove the piston again, and compress the rings again until you feel with your fingers that all the piston rings are fully compressed. This is very, very important. All right? Check with your fingers that all the rings enter in the grooves completely, and in that moment you can introduce the piston easily. Right? We are going to do the process right now. Okay? Right now you verify, you compress, and you verify with your fingers that all the rings are closed. All right? Yeah, this is the process. You can use other type of tool like this. This is good for gasoline. Yeah, this is good for gasoline engines. But for some small diesel engines, if you feel comfortable with that tool, use that tool. Use the tool that you feel comfortable. Yeah, some people use this tool. That's okay. There are millions of compression rings tools. You need to use the tool of your preference, right? With that tool, you can compress the rings, and right now the rings are fully compressed, ready to be installed in the block. Okay, right now we are going to continue with the process. We are going to install, okay, the compression ring. I check that the rings are fully compressed, and now, okay, my friends. All right, I recommend use a plastic hammer and use or rubber hammer, both of them, and two people. One people in front of the piston and other person in the other side, trying to receive the connecting rod and avoid that the connecting rod touch the cramping on the crankshaft and damage the cramping. You need with your fingers help in order to introduce the connecting rod easily and protect the metal, the surface of the crankshaft. Remember that this is polished like a mirror, no? Okay, we are going to do the process. With the hammer, it's important be 100% sure that the tool, the steel of the tool, be completely flat against the surface of the block, like this. Exactly. You punch exactly. You be 100% sure that the surface of the tool is in contact with the block, and right now pass completely through the other side. Let me repeat the procedure. You compress the rings, fully compress it, and now with the hammer you be 100% sure that the tool is flat with the block. And now you punch slowly, and other person in the other side receive the piston. Other person in the other side receive the piston and organize the position. Look, like this, like this, like this. Correct. And right now, once again, you lubricate the surface, you lubricate this surface. You prepare the cap of the connecting rod. Be careful with the cap. The cap should be in the position. Remember that the cap of the connecting rod only have one position. If you switch the position, probably don't match properly. And after that, when you try to turn the crankshaft not turn. Alright? Be careful with that. We are going to verify that the cramping be properly lubricated, and also we are going to verify that the cap closes properly with your hands in the position in between the cramping and the connecting rod. Okay, we are going to continue. All right, right now you bring the cap and you check you lubricate the cap properly. You introduce the cap in the position according with the marks, and with a regular ratchet, you torque, no the torque recommended by the manufacturer. You torque with your hands, pretty close, but not with the final torque. Okay, you torque completely, and after that, when you finish, you lubricate and you rotate the crankshaft with a socket and a ratchet. You lubricate properly, and now you exactly, and you verify that the connecting rod is spinning properly. This is spinning properly, and you lubricate again. Lubrication, that's the secret. Excess of oil. All right. We are going to repeat. You bring the connecting rod, you push the connecting rod against the crankshaft. Now you lubricate the area, and you locate again the cap of the connecting rod. And you torque with your hand, not with the final torque. You approximate the cap against the connecting rod. Now you tight with the socket and the ratch, and exactly with the appropriate socket. Be careful with the head of the bolts. Be careful that there no play in between the socket and the head of the bolts. Now you tight. Exactly, you tight both of them. You lubricate again. More oil. And now you try to turn the crankshaft, and you verify that it's completely free. And you do the same process with the next piston and next connecting rod and next cylinder and next cylinder. That's the process. Once again, my friend, the secret is keep the area properly lubricated. You install one piston and you rotate with your hand 2 times, 3 times the crankshaft. You install the next piston and you rotate with your hands 1 time, 2 times, 3 times. Yeah, this is very, very, very important. Keep the engine rotating free. If in one moment in the rotation of the crankshaft the engine stops, you know the problem is exactly in this piston. Let me remove the cap. Probably I install the caps. Oh yeah, when I switch the cap, right now rotate. I make a mistake. I switch the position of the cap. Alright? Always you need rotate with your hand the crankshaft in this process. Okay, my friends? Now we are going to do the torque. We are going to apply the torque appropriated according with the manufacturer recommendation. According with the manual, you select the torque appropriated for that specific connecting rod, and you apply the torque. You use the socket appropriated. The black sockets are excellent, and you torque the connecting rod according with the manufacturer specification. Yeah, when you hear the click on the tool, you stop. Now continue. You hear the click and you stop. Like this. In this moment, you are pretty close. Exactly. You hear the click and you stop. Once again, in the other one, you hear the click, and no more. Finito. That's it. And once again, rotate the crankshaft. More oil and rotate the crankshaft. Once again, rotate the crankshaft. Before and after the torque. Rotate the crankshaft. What happens if in this moment, when you apply the final torque, when you try to rotate, it's not possible? Something is wrong. You need to remove the cap, check, added oil, put back the cap, and okay. Probably, normally the problem is that the people switch the position of the cap. Other possibility is that the people never verify the bearings with the plastic gauge, and those bearings are too thick. When you apply the torque, close completely, and it's impossible to move the crankshaft. Use the plastic gauge. Check with plastic gauge before you install the bearings. It's too much time. Yeah, sorry. That's the procedure. The professional procedure. Okay, now my friends, we are ready to do the diagnosis. What happened? In this moment, we have more tools, more concepts in our brain to do a diagnosis. We are going to check what happened in the combustion chamber. What happened with the piston? What happened with the piston rings? If salt water enter, or coolant, or too much fuel, or too much air. Okay, we are going to analyze what happened with the piston and the piston rings in each scenario. The first one, look at this, lack of lubrication. Oh yeah. Look at the wall of the cylinder. Look at this. This is completely welded. The rings and the pistons are completely welded. Lack of lubrication. Oh yeah. What happened? Where is the problem? in that particular cylinder. You have that problem only in one cylinder. What happened? The oil jet on that cylinder was clogged. No oil, no spray of oil in that cylinder. The other cylinder is good. What is the problem? Probably internally in the block, the cavities are clogged. Why? Why? Because the oil is dirty, or because the people use additives. I don't recommend use additives for the motor oil. I don't recommend use additives. Be careful, never use additives, because the additives is a gel. When the temperature decreases, the gel clogged those cavities. Never use additives. Okay, this is the situation. This is the situation, lack of lubrication in one cylinder, and this is the final result. Lack of lubrication is not necessarily a problem with the oil pressure. Probably you have good oil pressure on the oil pressure gauge, but you have lack of lubrication only in one cylinder. Yeah, this is possible because you have the oil jet clogged in that particular cylinder. The problem is focused in one cylinder. When you remove the head, you discover that the other pistons are working good, and the problem was only in one cylinder, and you can fix it, like I explained before, and I am going to explain later more details to solve that problem. Okay, all right, this is lack of lubrication. Big problem. When you have lack of lubrication, what is the first symptom? The temperature goes up, and you have on the temperature gauge, the needle of the temperature gauge going up with respect to the normal position. And probably you have a code on the computer, high temperature. But the high temperature was focused only in one cylinder, right? This is the first one. The second one, other lean mixture. Yeah, with lean mixture, you have also high temperature. Yeah, but the high temperature was focused in that particular cylinder. Only in one cylinder. Why? Yes, because the mixture, air, the ratio, air and fuel, right now is more air and a little amount of fuel, less fuel than the recommended in the stoichiometric ratio. And what happened internally in the combustion chamber? The temperature increased dramatically. And remember, the melting point of the aluminum is lower in comparison with the melting point of the iron. And of course, the first element affected in the combustion chamber is the aluminum, because the rest of the elements in the combustion chambers are in steel, hard steel. All right, and the face of the piston, can be melted like this, because the engine was running with lean mixture for too much time. We are going to study later the millions of possibilities for that situation. Lean mixture, probably the injector in that specific cylinder open improperly, and never inject the amount of fuel necessary, inject less fuel, and the mixture is lean always in that cylinder. Yes, or the problem is in the fuel injection pump. The output for that cylinder in the fuel injection pump have a low pressure. You need to calibrate the fuel injection pump. There are millions of possibilities for lean mixture in one cylinder. Yeah, but normally the problem is on the fuel injection pump or on the injector. All right, this is the situation. The temperature increased dramatically. Of course, you have the code related with high temperature, and of course you have the gauge of the temperature gauge going to the maximum, to the red area. That's not good. All right, this is one situation. Look, this is other picture for lean mixture. This scenario is the worst scenario. The piston is completely melted. Yeah, this is a real picture. This is the catastrophic consequence when the piston, when the engine is running lean for a long period of time. Okay, if the temperature, I explained at the beginning of this course, you need to check always two gauge, the oil pressure gauge and the temperature gauge. Both of them are very important. If the oil pressure decrease the normal position a little, you have problem. You need to stop and identify what is the problem. If the temperature gauge pass the normal position and goes into the red area, stop and check. Because if you continue running the engine with the needle in other position, soon or later you destroy the engine. Because be careful with that. Okay, this is other possibility. Other common possibility is rich mixture, carbon deposits. What is the color of the smoke? When you have carbon deposits, black smoke. Black smoke, like you have here. Look at the head of the piston. The head of the piston is fully of carbon deposits. That's not good. Excessive amount of fuel in the mixture. You remember the stoichiometric measure? Exactly. Right now, the amount of fuel is more than the air, and this is the consequence. Look at the head of the piston. It's saturated of carbon deposits. But exactly the same is with the valves. If you check the intake valves, those valves are completely saturated of carbon deposits. This is good, especially in the intake valves. No, because if those pieces of carbon deposits are in the edge of the valve probably don't close properly, and you have detonations and flame. We are going to study later. No, the carbon deposits are the enemy of valves and combustion chambers. Yeah, there are additives. The only additives recommended for me are the additives for fuel, because the majority of the additives used in the fuel, they improve the cleaning of the combustion chamber. This is good, and improve the resistance of the fuel to be emulsified with water. Okay, I recommend additives for fuel. I don't recommend additives for motor oil. I don't recommend additives for transmission oil. I recommend additives for fuel, and I recommend also additives for coolant. The SCAs, supplemental coolant additives. We are going to study in other chapter. Those additives are excellent. Those are the only additives that I recommend in both scenarios, in fuel and in coolant. Okay, this is the situation when you have black smoke, carbon deposit. Be careful with the carbon deposits. Other common problem is this. The engine is burning too much oil. Look at the head of the piston. It's saturated with oil. It's grease, it's oil. And what is the color of the smoke? Blue smoke. Blue smoke. Excessive amount of oil. Where is coming that oil? You remember? From the valves. Because the seal on the valve guide is broken. Because the tolerance in between the stem of the valve and the valve guide is too much. Too much play, and the oil penetrates the combustion chamber. Because the piston ring. Okay, if the piston rings are completely broken, probably the oil passed. That's true. But in normal condition, no. We talked in the previous episode about that. Okay, this is the situation when excessive amount of oil, and we are going to study later what is the code related with that problem. Yeah, because each problem produces a code in the computer. This is the other common problem. When the coolant enters in the combustion chamber. Coolant, no salt water. Yeah, of course. Look at the coolant on the cylinder. When you remove the head, immediately you found the coolant. If you check in the computer, look, those are the cavities. Those are the cavities for the pass of oil. And this one is for coolant. This is for coolant, and this is for oil. Look, the coolant and the oil is pretty close. When the engine is overheating, the head is bended. When the head is bended, what happened with the gasket? The gasket is free, and the coolant mixed with the oil. Finito. The coolant pass, enter in the combustion chamber, and if you check the expansion tank, you found that this situation. Look, the oil is emulsified with the coolant, and this is the color, milky oil. Yeah. And the color of the smoke is white smoke. This is the color of the smoke. The other common situation is this. Salt water enter in the combustion chamber. This is catastrophic. The engine is out. Look at the head of the piston and the head valves when salt water enter in the combustion chambers. Look. Ay, ay, ay. Look at the amount of salt water destroyed the piston, destroyed the cylinder. You see? You see what happened with the head, with the valves, with the face of the combustion chamber here. Look here, the corrosion. You remember in a previous episode I explained that if you discover that the salt water entered in the combustion chamber, you can recover the engine if you act quickly. You identify that salt water entered, you remove the injector, you suction the water, you added mystery oil, you try to turn it with your hand, and you can recover the engine. Oh, I am going to check on Monday. No, you need check immediately. You need remove the salt water immediately. You need introduce oil in order to protect the area. Okay, my friend, this is the situation. In general, it's catastrophic. Because you remember what happened with the piston when the salt water entered, expand and block the engine. That's not good. This is the worst scenario. This is the worst scenario. I never recommend that situation when the salt water enter in the combustion chamber. In that case, you don't have white smoke because immediately the salt water entered, the engine stopped, and probably the engine is broken. In some cases, you can recover. Like I explained before, the procedure, step by step, to do that procedure. Okay, my friend, those are the most common situations when the salt water enter, or coolant, or excessive amount of oil, or a lean mixture, or rich mixture. I hope you enjoyed this video. We are going to use part of this video in the future when we create a table with the codes related with each particular situation. Thank you.